Hey guys, just doing the quick solutions video for the 2024 General Maths exam. It's the actual one they ran, so let's see how quickly I can do this. This is the first time I noticed that they had only 8 questions, not 9 questions. Normally it's 3 of each topic that's examined, but here one of them had 2. So you got 130 minutes for 90 marks. A mark a minute is a good way to operate for speed-wise. Hopefully you can see with me explaining all of this while I do it that you can operate faster than that. So a dog grooming salon has 4 staff members. To groom a dog, the staff wash, trim and dry and brush. The staff clip the dog's nails and clean their teeth. Manager wants to determine which task the staff member should do to minimize total completion time. So just doing Hungarian algorithm. Average time spent in minutes by each staff member to complete the task. Interpret the meaning of number 25. Owen takes 25 minutes to dry and brush. The Hungarian algorithm has been applied to the information from table 1, resulting in the following. So they did our job for us. Complete the table below. So they've done the steps of the Hungarian algorithm. They haven't identified zeros yet. Alone in its row? No. Alone in its column? Yes. Alone in its row? No. Alone in its column? No. Leave it alone. Alone in its row? No. Alone in its column? Yes. Row? No. Column? No. Row? Yes. Leftover one. Don't need to think about it. Using the reduced array, complete the table. Oh, I haven't. No, I can do that now. I've selected my zeros. Delilah, task. What was Delilah? Delilah, Owen, Gracie, Zephyr, wash, trim, dry and brush, nails and teeth. Delilah is set to trim. Time taken was 40 minutes. Owen, wash. He took 33 minutes. Gracie was nails and teeth. And how long she'd take? 22 minutes. Zephyr, dry and brush, 26. 26 minutes. What is the total time? 40 plus 33 plus 22 plus 26. 121 minutes. Please turn over. The manager would like to launch a new advertising campaign. Guarantees to groom a dog in under 2 hours and the next groom is free. Manager wants to investigate allocating more than one job to Gracie. So let's hammer Gracie. It would allow them to use this campaign. Here's the new one, a new array. So they put it in the matrix for us. State why the new array must have an additional column of zeros. Well, Hungarian algorithm. Only works on a square matrix. You need it to be square. After completion of the first 2 steps, the following array is achieved. Draw lines on the above array to show that the optimal solution has not yet been achieved. What's the most zeros I can hit? I can hit 3. Next most I can hit is 2. I can hit another 2. And I can hit another 2. That took 4 lines, 5 rows, so not achieved. I need 5 lines for the 5 rows. Complete the remaining steps of the Hungarian algorithm and determine the updated minimum completion time. So redo those lines there. That was first, second, third, fourth. The order doesn't matter. What's the smallest uncovered number? It's 3. Add this to double covered. So 2 plus 3 is going to be 5. Leave single covered alone. Double covered 14. Single leave alone. Double covered add. Single covered leave alone. Uncovered take. Leave take. Leave. Leave. Take. Leave. Take. Leave. Leave. Take. Leave, take, leave, leave, take, leave, take, leave alone. Now we can cover again. 3 zeros, 1, 3 zeros, 2, 3 zeros, 3, 2 zeros, 4, 1 0, 5. So that was 5 lines for 5 rows. Let's select our zeros. Alone in the row? No, but it's alone in the column. Alone in the row? No. Alone in the column? No. Leave it alone. Alone in the row? Yes. Row, column, no. 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 Oh, these are too hard to select. So, what do we notice here? These 2 pairs of zeros are matching in the same columns and the same rows. So that's going to be a multiple optimal solution scenario. And if those are selected, the only leftover is this in the dummy column that we added. So what does that suggest? What do we have? What was it again? Delilah? I remember. Owen. Gracie got shafted. She had to do 2 now. And Zephyr with a weird name. So Delilah remained. Just going to copy and paste this. And then delete it after. Because I don't have the paper. Delilah was 40. Owen was 25. Gracie was these 2 rows. She could either do she could do wash 32 and then that's wrong. I stuffed that up. I forgot about the dummy links here. Dummy column. There was a bunch of zeros there. So that's shifted over. Doop, doop. Gracie could do those two, and Zephyr got nothing because he's too, or she or whatever, is too slow. So Gracie could do wash, 32, and then take 22 for nails and teeth, and Zephyr would do nothing because too slow. Or, because it's multiple optimal solutions, Delilah was always going to do the trim, Owen was going to do dry and brush, but then, see, the first time I went around I did 32 and 22, so this time around I'm going to do that 32 and 22, so 22 and 32, and Zephyr again, he's no good at doing the job, so let's add those together. 40 plus 25 plus 32 plus 22, 119 minutes. Delete this, erase this. Remaining steps, determine the updated completion time. Which staff member is no longer required? Zephyr. State why the dog grooming salon guaranteeing customers to groom a dog in under 2 hours on the next groomer's fee should be considered unreasonable. Well, their new grooming time is 119. That's 1 minute off. So total time is very close to 2 hours at 119 minutes. So no room for error. What else? Assumes all tasks completed perfectly on time. Assumes Gracie is not slowed down by doing 2 jobs. It's a bit unfair on her. She better get paid more. Be willing to do that. Question 2. The age at which Australian children start walking is used as a marker for childhood development. The data collected is normally distributed. Mean of 14. Standard deviation of 1.75. This is start walking. Calculate the proportion of children that starts walking between ages of 10.5 and 14. So it's asking for the proportion. So it's normal CDF. The lowest is 10.5. The upper is 14. The mean was 14. Standard deviation was 1.75. Calculated time, stat. No, it's not stat. It's been a while. Second vase for distribution, normal CDF. 10.5, 14, 14, 1.75. Paste it. So that tells me 0.4772 to 4 dp. Therefore, 47.72% start walking between 10.5 and 14 months. Federal government health guidelines recommend that state governments offer funding assistance if a child is not walking by the age of 17 months. Not walking by the age of 17 months. So they need assistance if their walking is beyond or above 17 months. So we're finding the percentage, so that's normal CDF again. 17 is the lowest I'm interested in. Everything above that is infinity to the right, so E99, 14 and 1.75. Second dist, normal CDF. I was interested in 17, wasn't I? E, second comma, 99, 14, 1.75, everything's the same. 0.0432 to 4dp, therefore 4.32% may require funding. In South Australia, 19,502 births were registered in 2022. How many of these children expected? Well, I have the percentage, and it is a decimal, 0.0432 times by 19,502. 0.0432 times by 19,502. 842.49 to 2dp. You can't have part of a kid, so therefore 842 expected to require funding. State Government Health Authority provides funding assistance to the oldest 10% of children not yet walking. So we've been given the percentage, finding the minimum age. So we're given the percentage. It's an inverse normal question. Top 10%. So I can do so. I have a newer calculator here, so I can set the tail to the right. So top 10%, 0.1. The mean was 14, the standard deviation 1.75, and I set my tail to the right. 0.1, 14, 1.75 right. 16.24 months to 2dp. If you've got an older calculator, or if you have an older calculator, you cannot set the tail. So by default, your tail is always to the left for inverse normal if you have an older calculator. So if your tail is always to the left and you want to know where the top 10% is, well, the top 10% is the same as the bottom 90%. So you would put this in. This is for the old calc. No tail setting. That's what you put in for the old calculator with no tail setting, and notice that you get the same exact answer. – 16.24 months minimum to get assistance. Okay, so just showing you both calculator styles, taking a bit longer, but hopefully you'll see that if you're on top of the business, you'll be able to do the exam fine. Is the state government providing enough funding assistance according to the federal government recommendations? Tick the appropriate box to justify your answer, to indicate your answer and justify. Let's have a look. States giving funding to kids 16.24 months and older whereas the federal government recommends they get funding if they're not walking by 17 months, which is older than that. So yes, state gives funding at 16.24 months and older, which is younger than the 17 months and older. For federal. Also, what do we see from this? State government covers the oldest 10% of kids, whereas the federal only covers the oldest 4.32% kids. Also, state covers oldest 10%, while federal only covers oldest, what was it, 4.32%. While other markers for childhood development are the age at which children start to speak and when their first molar, I was reading my own writing, two other markers. Speaking age, normally distributed, 17, standard dev 3, first molar tooth eruption, mean 14, standard deviation 3. Diagram below shows the probability distributions for two of the three markers for childhood. Fill in boxes A and B. Let's do our calculations. Height is equal to 0.4. Over standard deviation of 3. .13. The height of these two is going to be the exact same because they both have a standard deviation of 3. But there is nothing centered on 14 with a standard deviation of 3. So what do we have? We have 17, standard deviation of 3. The normal distribution ends at 3 standard deviations. Higher and lower. 3 times 3, 9, 17, 26. So we have it ending at 26 and 8. And this has a mean of 17. This must be speaking age. We have 14 here, but the standard deviation of this, 14, but this ends 14, 15, 16, 17, 18, 19, 20, 22, 23. This one, if it was, this should end at 23, but it doesn't. It ends well before that. So what was this? Standard deviation of 1.75. So that should be walking. Should be walking age. Using the info provided throughout this question, draw the missing probability distribution on the diagram above. So now we're going to draw this one, first molar tooth. It's going to have a mean of 14. So it should be directly under this tall one. But it's got a standard deviation of 3 months. So 3 times 3 is 9. It should finish at 23, around about there. And it should finish at 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It should finish at 5, around about there. Point of inflection should be at 17. And it should be at the same height as this, 0.13. So speaking age height was there. So we should have the matching height. Point of inflection halfway down at 17. Point of inflection halfway down at 11. Should draw these better. 17, 11, halfway is about there. Halfway is about there. Okay, concave. Worst line ever. Still worst line ever. Still the worst line ever. Concave. Convex. Convex. Probably not perfectly symmetrical. I am drawing on an iPad. That's what you're going to get. So I filled in the boxes. Draw the missing probability distribution. Federal government health guidelines recommend that children who are not speaking by the age of 24 months should start receiving funding assistance with speaking. Speaking. More likely, we're looking for probability, so normal CDF. Speaking is 24. 24 is the lowest. And we are interested in anyone above 24. And speaking had a mean of 17. Standard deviation of 3. Second dist, normal CDF, 24. Second comma, E99. 17, 3, paste, 0.0098 to 4dp, therefore 0.98%. Walking, that was from before, normal CDF, they got assistance, I think it was a 17, E99, it was 14 and 1.75. I've already done the maths of that, so I'm just going to copy it down, 0.0432 for DP, therefore 4.32%. Therefore, more likely to need funding with walking at 4.32% chance compared to speaking at 0.98% chance. Please turn over. Question 3. Peter is considering selling her house and moving to a larger home to accommodate her growing family. Network diagram below shows a series of tasks that need to be completed for this to happen. Explain why the dummy link X is required in the network diagram. What is the purpose of it? It's to split E and D, otherwise E would be there. And G will require E2, which is not. Not needed. No, sorry, it's C. No. This dummy link is here to make sure that C is only a requirement for E, but not also G. Otherwise, if there was no dummy link here, C would go straight to there. And this E would be linked up there, so G would require both C and D. No, it's not. What is the C doing? What is the dummy link doing there? Okay, that's what it's doing. The dummy link is preventing E from needing both D and C. If the dummy link wasn't there, C and D would join up there, E would be joined there too, and therefore E would require C, which is not what the pathway shows. So ensures that E only requires C as a prerequisite, while F and G have both C and D as prerequisites, but not E. No, you don't need the not E. Ensures that E only requires C as a prerequisite, while F and G both have both C and D as prerequisites. Yeah, and make sure E only has C. Ensures that E only requires C as a prerequisite, but F and G have both C and D as prerequisites. Done. Wow, I don't know why that was so hard. The following precedence table has been completed for the above network diagram. The network diagram should have two dummy links. Using the info from the precedence table, draw the second dummy link on the network diagram above. So dummy links are needed when you have tasks that share some but not all the same prerequisites. So you can see that's the case there, and that's the case here. So the dummy link goes from the end of the shared prerequisite, so the shared prerequisite is C. It goes from the end of the shared prerequisite to the task or tasks that have other prerequisites. So C, the dummy link is going to go from C to both F, because that has other prerequisites, and G, because that has other prerequisites. And then this is the shared prerequisite here. So the dummy link goes from the end of G to the start of J. So we need to draw the second dummy link above. We already have the dummy link coming from the end of C to the start of F and G, which is what we have drawn here, but we don't have one going from the end of G to the start of J. So end of G, start of J, it's going to do that. Okay. Using the info from the precedence table and network diagram, identify the statements that are correct. Task H is on a critical path. Don't know that. Do we? We do know that because there is no slack time. Let's do that. No slack time, no slack, no slack, no slack. H has no slack time, so it's on a critical path. A delay in the completion of task D will always cause a delay in the start of task F. Well, no, because D's got slack time, so no. Task F has 2 days of slack time. Task F, it has 1 day of slack time, 9 to 10. A delay in the completion of task E will increase the minimum completion time for the network. Task E is on the critical path, so it can't be delayed, so that must be. State the critical path and the minimum completion time for this network. What do we have circled? No slack, A, C, E, H, J. A, C, E, H, J. How many days is that going to take? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 days. Is it days? Days. Okay, that's that networks question done. Nia has started her first job, earning $67,500 per annum. Nia's employer, 11.5%. She wants to do an extra 1%. Account earns 7.2, compounded fortnightly. Show that 325 is deposited. We're at 11.5%, 0.115 times by 67,500. Where's the calculator? 0.115 times 67,500. That's what's going into her super per year from the employer. She's doing 1%. $675. 7, 6, 7, 8, 9, 10, 11, 12, 13. 6, 7, 8, 9, 10, 11, 12, 13, 14. That's yearly. $8,437.50 divided by 26. 8,437.5 divided by 26 is $324.52 to 2 decimal points. Therefore, approx. $325 per fortnight. Calculate the balance in Nia's superannuation account after 40 years of Nia working in this job. N is going to be 40 years times by 26 because it's happening fortnightly. I don't know what that is. Put it in later. Her super account earns 7.2% per annum PV. It doesn't say she starts with anything, so start at 0. PMT, we're going to use our number. So she's putting $324.52 into the account per fortnight. FV, we're finding the balance, so that's what we're looking for. PY and CY are the same. So calculator, apps, finance, TVM. 40 lots of 26, 10, 40 fortnights, 7.2, nothing, negative 324.52, both 26, make sure it's on end, alpha, enter, 196,234.39 to 2 decimal points. Therefore, $1,962,134.39 after 40 years. Calculate the amount of interest that Nia's super account will earn over the 40 years. Interest on an investment is equal to the FV, what it grew to, 196,2134.39. Minus starting amount, which was nothing, plus the total in payments, which is 1040 payments of $324.52. 196,213.4.39. Take away 0 plus 1040 times by 324.52. We get $162,463.59 interest earned. So, state one reason why the balance in Nia's super account could be lower than the balance calculated in Part A2. Super account rate could go down. Her deposits could go down. Changed job. Changed hours. Any reason like that. Hence, describe a strategy that Nia could implement to achieve the balance calculated in part A2. Make larger contributions than 1%. Find a higher paying job. So that page, at retirement, Nia deposits $2 million into an annuity account. Interest rate 4.6, compounding weekly. She wants to withdraw weekly for 30 years. Big spender. In 30 years times by 52 weeks in a year. Just been doing DIs, that's 1560. Interest rate 4.6 PV. She deposited 2 million, so she's starting with 2 million in the account. PMT is what we're solving for. She's going to withdraw until she's done. PY and CY. Weekly, so 52. Apps Finance TVM Solver 30, lots of 52. 4.6 negative 2 million. Not one. She doesn't want a dollar in there. 52. Alpha, enter. 2364.43 to 2 decimal points. What's that? Therefore, approx 2365 weekly, because it was $2364.43. Calculate the time taken in years for the balance of the annuity account to reach $1 million. So, solving for n, because it's time, the interest rate was 4.6. We started at 2 million in the account. We were withdrawing you're withdrawing it. So you're getting that money, 2364.43. You're not going to be withdrawing for as long because we're only getting it down to $1 million. PY and CY, both 52. 4.6, negative 2, not negative, why do I keep doing that? 2364.43. We only wanted it to get to $1 million. $1030.03 to 2 decimal points. Time taken in years, don't lose a mark there. 1030.03 divided by 52. 19.81. That's to 2 decimal points. Using mathematical reasoning, explain why your answer to part C is not halfway through the expected 30-year term of the annuity account, because it's what compound interest rate. Because annuities earn compound interest, compounding interest less interest is earned by the second half of the balance, the remaining 1 million. So takes less time to burn through the last half with the payments, withdrawals, sorry. Because the interest earning isn't as much in the second half to make up for the withdrawals that you're making. Okay. Oh, Nia's still going. When Nia retires, her initial cost of living is $1,000 per week. She'd like to maintain her standard of living through her retirement. Nia's weekly cost of living, compounding, that's the inflation formula basically. Complete the following statement to best explain what the value of 1.031 represents in the context of the scenario. The value is 1.031 indicates cost of living is predicted to, well, that's larger than 1, so increase, not decrease, by 0.031 times by 100 is equal to 3.1% per annum. The term used to describe this measure is inflation. Using the equation from part D, 1, predict Nia's weekly cost of living 5 years in. Cost of living 1,000 times by 1.031 to the power of 5,000 times by 1.031 to the power of 5. $1,164.91 to 2 decimal points. Per week. Predicting the time in years it would take for Nia's cost of living to reach 2,365 per week. So we're in general maths. We can't solve this using natural logs. So basically we're solving the equation of when does her cost of living formula reach 2,365 when does that cost of living formula reach that? So y1, we're going to graph to one side of the equation, 2,365. y2, we're going to graph the other side of the equation, 1,000 times by 1.031 to the power of x. Y equals 2,365, 1,000 times by 1.031 to the power of x. Graph it, we're not going to see it. Zoom out until it's definitely on the screen. Okay, we can see the exponential function there. Now we can see the horizontal line at 2,365. Second calc to trace, intersect. First curve is 2,365. Second curve is the exponential. Guess. I don't really want you to guess. I want you to find the answer. Intersect at 28.1952, 2365. That's to 4dp. So therefore 28.20 years to 2dp to reach 2,365 per week. Using evidence from parts C and D, provide one reason why it could be considered reasonable for Nia to maintain her standard of living through her 30 years of retirement. What is she withdrawing? She's withdrawing $2,364.43 from her super. That's like $1, just over $1 less. So what could we say? C shows she can withdraw $2,364.43 a week for a full 30 years, and her cost of living only exceeds that at 28.2 years shown in D, which is almost all the 30 years. She could choose to withdraw slightly less early on to make up the 1.8 year difference. Also, that is a lot to spend weekly. So it is reasonable with just a minimal adjustment needed. Something like that. The evidence shows that she's pretty damn close. That's the idea that they're trying to get to here. She's pretty damn close. She could only modify things the tiniest little bit and make it last 30 years. There is no question here. Question 5. Australian Vet Association recommended owners take their cat to visit a vet annually. This is cost versus cat's age in years. The linear regression has been done for you. It's got a higher coefficient of determination. Using the linear model, predict the cumulative vet costs of a 9-year-old cat. Cost for 9, 113, 9 plus 1172. Calculator's on the wrong side. Second quit, 113 times 9 plus 1172, 2189. 2189 for a 9-year-old cat. If a cat does not visit a vet annually as recommended, total cumulative vet cost for a cat over its lifetime are shown below. But I haven't done the linear regression here, so we need to do it ourselves. Edit 0, 2, 4, 6, 8, 10, 12, 400, 850, 1700, 3650, 70, 200, 11, 200, 14, 500. Linear regression, stat, calc, lin reg, list 1, list 2, calculate. That tells me C equals 1223.21. T, take 1696.43, rounded to 2 decimal points. State why the exponential model would be a better model from table 7. Multiple reasons. R squared is higher for exponential, square root of 0.98 0.9899 to 4 dp. So exponential is very strong correlation for Pearson's correlation coefficient. Also, y int of negative 1696.43 is very different to the actual y int of $400. The data doesn't fit with the correlation. No, the data doesn't fit with the linear regression model that's been given. Interpret the meaning of the A value from the exponential model shown in Table 8 in the context of the question. Cumulative cost of a cat from birth, 0 years old, is the y-intercept, which is $475. Using the equation for the exponential model from Table 8, predict the total cumulative vet costs of a 15-year-old cat that does not visit the vet regularly. So this is not visiting the vet. Cost 15,475 times by 1.36 to the power of 15. Where's my calculator? 475 times by 1.36 to the power of 15. $47,138.46 to 2 decimal points for a 15-year-old cat. Why not just buy a bloody car? Probably a better idea. Comment on the reasonableness of your solution to part B. For unreasonable as it is a the data only goes up to 12 years. It's a 3-year extrapolation. Even if the correlation was very strong. Using technology or otherwise, find the coordinate of the point of intersection for the linear model and the exponential model. So they want us to graph both of these. 113x plus 1172, and we're graphing y2 is 475 times by 1.36 to the power of x. Y equals 113x plus 1172, and 475 times by 1.36 to the power of x. Graph them. Start from a zoom standard. Let's see if we can actually see this. Zoom out. You can't really see it very well. Second, trace for calc, intersect, first line, second line, guess, intersect at 41623.71 to 2 dp, because that's 3.9974 rounds to 4. Interpret your results from part C1 in the context of the question suggests that after 4 years, that's from here, both cats, because the first model was taken to the vet, both cats taken to the vet yearly and cats who are not will cost $16, $23, 71 regardless. Okay. Next one, question 6 for the upcoming Taylor. Oh, look at Sace trying to be all topical. Ticket agency A proposed the ticketing process represented by the network diagram below. Times for each task are given in weeks. State the time to complete task B. It went from 3 to 7, so 4 weeks. State the time taken to complete task F. (9 to 17, 10, 11, 12, 13, 14, 15, 17. It went forward 8, but we can't trust that because this is another option. So we need to check the backwards. It has to be based on the backwards scan. 17 take 10 is 7 weeks. Task H has 1 week of slack time. State how long it takes to complete task H. This is probably easier just to do the proper scans. 0 to 3, that's 3. 3 to 7, that's 4. 7 to 9, that's 2. 7 to 9, that's also 2. 17 take 10, that's 7. 17 take 9, that's 8. Dummy link has 0. 24 take 21 is 3. 24 take 21, also 3. 21, 21. 21 take 17. 17, 89, 20, 21. G must take 4. 21. H has a slack time. H has a slack time of 1 week, so it has a later starting time of 18. So 21 take 18, H is going to take 3. Say how long it takes to complete task H, 3 weeks. State the critical path or paths for this network. No slack, no slack, no slack, no slack, also no slack. A, B, C, E, G, K. B, C, E, what was it again? G, K, or A, B, C, E, G, J. State why task A and B must always lie on all critical paths. There are no alternate path. And there's no paths around A and B. There's no alternate paths around A and B to reach the start node of C and D. There's only one way through them, so they must be the critical path. Rival ticketing agency, ticket agency B, has submitted an alternative plan for Taylor to consider. They've done the forward and backward scans partially. I don't like these. I always like to do them myself. 2, we know B takes 3, add 2 plus 3, 5. Okay, we've got multiple pathways here. 5, 6, 7, 8, 9, 10, 11. It could be 11. Or 6 plus 4, 10. No, largest number, 11. This takes 0. 2 plus 6, 8. 8, 9, 10, 11. This one, 11, 12, 13, 14. Okay, the rest of the earliest starting times have been done. Latest starting times, 22. 22 take 6 is 16. 16 take 5. Could be 11. 22 take 4. 18. 18 take 4. 14. So 11 and 14 on this line. 22 take 5. 17. 17 take 3. 14. 14 take 6. 8. 14 take 4. There's a dumb link through there, so leave that. 11 take 3 is 8. 8 take 0 is 8. 14 take 4 is 10 along F. 8 take 3, 5. 8 take 4, 4. 8 take 6, 2. So 8 take 4. 4 on C. 8 take 3. 5 on B. That's done. On the network diagram, complete the... Oh, I just did the forward and backward scan. State the latest starting time for task B. It's 5. 5 weeks, because the box with 5 is over B. Ticket agency B has underestimated the time taken to complete task J by 4 weeks. Task J is now going to take 8. 11, 12, 13, 14, 15, 16, 17, 18, 19. That's going to be 19 now. 19, 20, 22, 23. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now, 19 plus 4 is going to be 23 now. Given this new info, provide mathematical evidence to show which ticket agency Taylor should select. If J now takes 8 weeks, a new crit path is formed, taking 23 weeks. 23 weeks is still shorter, because I remember that took 24. Then agency A, so select agency B. Question 7. Study was conducted to investigate whether there is a relationship between public health expenditure of a country and happiness. P is the amount that the government pays as a percentage of their gross domestic product. Happiness, score out of 10. Oh. They removed the table for copyright reasons. Who sakes, what are you doing? Okay, I need to get the exam. How do I do this? Is the video going to stop? I'm going to take a photo of the... Can I get a photo? Camera, allow. Go back to Notability. Take a photo. Of the table that they got done for copyright. Look at you, Sace. Use that photo. Pen go. Let me crop this thing. There it is. There's the table. Look at that. Hopefully the video didn't stuff up. We'll find out if I wasted my hour and a half exam time. There's the table that they were talking about that they removed because they have that PDF on the website. State the value of Pearson's correlation coefficient for a linear model. We need to put this data. Clear, 9.2, 8.5, 8.3, 8.1, 6.4, 5.5, 4.9, 4.3, 3.9, 3.8, 3.5, 3, 7.34, 6.89, 6.6, 7.05, 6.22, 6.13, 5.89, 5.76, 6.3, 5.29, 5.65, 5.19. And they want me to do a linear model. Stat, calc, lin reg, list 1 and 2. Pearson's correlation coefficient is not showing, so I need to go second, 0 for catalog. Scroll down to the D's for diagnostics. Diagnostic, turn it on. Turn them on, now I can go back to stat, calc, lin reg. Went too far, lin reg. So Pearson's correlation coefficient, R equals 0.9206 to 4 dp. Using the correct variables, tick the model which best represents the equation. That's wrong because it's not in context. P, public spending, was the independent variable, so it's not that. It must be the third one. In the context of the question, interpret the meaning of 4.564 from the equation. 0% expenditure. Countries. Have happiness index of 4.564. On the graph above, add the missing residual value. Calculator again. We've done a linear regression on the data already. So now I can go to stat edit. I can go to list 3. I can go second stat for list, and I can ask it, can you fill this column with the residuals? The largest bit of data was 9.2, and I noticed that there's nothing at 9.2 here. So 9.5 is there. 9.25 is here. 9.2 is going to be slightly below it, and 0.1853. 0.1853. 0.1 is going to be here. 0.15 is going to be here. 0.1853 is going to be slightly above that. So there, and erase. Add the missing residual value. Using your answer to part A and the residual plot above, give 2 reasons why a linear model would be considered appropriate for the data. Residuals are randomly scattered, no pattern. Residuals are not too large compared to the data, and R is close to 1 because Pearson's was 0.9206. Not the strongest, but it's strong. India recorded a happiness index of 4.02. Using the linear regression equation you selected in part B, using the linear regression equation you selected in part B, predict the percentage of GDP that India spent on public healthcare. Linear regression, 0.282p. 0.282p plus 4.564. Percentage. So they were 4.02 happy, 0.282p plus 4.564. Subtract 4.564 from both sides. (4.02) minus 4.564, negative 0.544, 0.282p. Divide both sides by 0.282. Divided by divide by 0.282. P is going to be negative 1.9291 to 4 dp. In the context of the question, comment on the reasonableness of your solution. Not reasonable, as this suggests negative public expenditure. Also, it is no one was that unhappy. The lowest happiness was 5.19, but their happiness was 4.02, so also it is an extrapolation. So unreasonable 2. Finland spent 7.3% of its GDP on public healthcare with a happiness index of 7.8. Using the equation selected in part B, calculate the residual value for Finland. This is new, I've never seen this before. Okay, the model predicts that if you spent 7.3%, 0.282 times 7.3 plus 4.564, the model predicts 0.282 times 7.3 plus 4.564. The model predicts you should have a happiness index of 6.6226, but they actually got 7.8. I almost swore there. Just play calculator. So residual is the actual data, actual minus predicted. The actual was 7.8 minus the predicted of 6.6226. 7. My calculator's gone haywire because I moved the thing. 7.8 minus 6.6226, 1.1774. Residual predicted 1.1774. Next page, question 8, last question. Janet and Bill are twins. They just sold their food truck business. After all expenses had been repaid, they each received a payout of 12 grand. Janet decided to invest her 12 grand payout with her bank. Janet's bank advertised interest rate of 4% per annum. However, some info is missing. Effective rate of compounding half yearly is the effective rate of an investment. So apps, finance, not TVM solver, you scroll to CEFF. You go 4 is the nominal. They say it's 4, but it's compounding half yearly. So you comma 2, 4.04. So EFF 4, 2 equals 4.04% per annum. State which compounding period option would be the most financially beneficial for Janet. Weekly is best, as it has the highest effective rate. Janet has also seen a 4.5% flat rate investment option advertised on a billboard. Table 11 shows the effective rate for this investment over several different lengths of time. Complete table 11 by calculating the missing effective rate. So this is one of those things that you are not asked to do in the timeline, but I gave you the steps for it. We need to see how much money I would get by investing a made-up amount. I'm just investing $100. The flat rate is 0.045 times by 10 years. 100 times 0.045 times by 10. $45 interest would be made. Therefore, total is $145 if I invested $100. So now we make it into a compound interest scenario and solve for I. 10 years. I started with $100 in there, no payments. I'm just letting it grow. FV, it grew to 145 and it's compounding once a year for the effective rate. Apps, finance, TVM solver 10. I don't know what that is. That's what I'm trying to find out. Negative 100, 0, 145, 1 and 1. Alpha, enter, 3.79% to 2 decimal points, 3.79 to 2 DP. Complete table 11, calculate the missing effective rate. Janet will invest the $12,000 for 5 years. She's been given 2 options. Interest compounding monthly at 4% per annum. Flat rate of 4.5% per annum. Show that she will earn approximately $50 more interest using option B. Option A, N is going to be 5. Compounding monthly, 1260. Interest is 4. PV, she's putting 12 grand. PMT, she's not doing anything. FV, PY and CY will both be 12. 64, negative 12,000, 12 and 12. Alpha, enter. That tells me 14651.96 to 2 decimal points. Option B, flat rate 4.5% per annum. SI equals principal 12,000 times by 0.045 times by 5 years. 12,000 times by 0.045 times by 5. 2,700. How much interest was earned here? Interest is going to be $2,651.96. $2,700 minus 2,651.96 equals $48.04. Therefore, approx 50 more. For option B, Bill took out a home loan 6 years ago to purchase his first property. He borrowed $510,000 from a bank offering interest rate 6.85. 6 years ago is important. Compounding monthly for 30 years. Bill makes the minimum monthly repayment. They tell you the PMT. Show the outstanding balance. N is 6 times 12, which is going to be 72. Interest rate is 6.85. PV equals, he took out a loan of 510 grand. PMT, we've been told, is negative 3341.82. We want to know the outstanding balance, so solve for FV, PY, and CY monthly. $72, 6.85, 510 grand, negative 3341.82. Alpha, enter. Negative 471,790.75 to 2 decimal points. Therefore, approx 472,000 after 6 years. Calculate the interest paid in the first 6 years of the loan. Interest on a loan equals 3341 payments times by the number of payments minus the amount of debt that I got down, which was 510,000 minus 471,790.75. 3341.82 times by 72. Take 510,000. Take 471,790.75. $202,401.79 interest. At this time, exactly 6 years into the loan, Bill decides to deposit his 12 grand payout into an offset account linked to his loan. State the new balance in which interest will be charged. 202,401.79 minus 12,000. $190,401.79. No, that's not right. That's the interest. What am I doing? Silly. I'm getting fatigued by the end of the exam. His debt is 471,790.75. Take away the 12 grand. Clear that. 471,790.75. Take 12,000. 459,790.75. That's it. Calculate the outstanding loan balance if Bill leaves his 12 grand in the offset account for 10 years. N 120. We'll show where we got that. 10 years times 12 is 120. So we got the debt down to 471,790.75. Could you give us a sec? I'm just finishing the 2024 exam. If you see any of the other guys coming, just let them know I'm finishing up a video of the 2024 exam. I'll tell them on YouTube. Oh, I don't know the photo. You just let them know. Okay. I'll be absent. Okay? Sorry, one of my students came in for the holiday tutorial, which is fine. I'm almost done, so we can pretend that Mr. T had a little toilet break or something, yeah? 120. But we took 12 grand off of that. Take 12,000. So 120 I is 6.85. PV was the 459,790.75, which I've taken the 12,000 off. PMT is negative 3341.82. FV is what we are solving for. Negative 336677.01. PY and CY is 12. Therefore, 336677.01 debt left. After exactly 10 years of the 12 grand being in the offset account, he withdraws 7 grand from the offset account to pay for some home renovations. Wow, this is really technical. Remainder of the loan. This is one of the trickiest ones they've done. 6.85. PV. He got the debt down to 336677.01. He withdrew 7 grand from there. So it's going to be 7 grand larger debt. It's not offset anymore, and we want to work out how long it's going to take to pay that off. So alpha enter. PV is 36677.01, but we added 7 grand to it, so it's going to be 343677.01. PMT was negative 3341.82. FV is going to be nothing. PY and CY are both 12, and that comes to 155.38 to 2 decimal points. With that offset withdrawn. And we are trying to find how much is he going to save by utilizing the offset account. So this is the remaining offset here. Okay, interest using offset. First 6 years. We were asked to work that out. First 6 years. 202,401.79, 202,401.79. 10 years at 12 grand. Offset is 120,3341.82 minus. They got the debt from 459,790.75 down to 336677.01. Man, so much maths. This is the hardest line question they've ever done. Times by 3341.82. Take 459,790.7. 75. Forgot to write that. 75. Take 336677.01. That was 277,904.66 interest in the 10 years of offset. And then remainder was 155.38 times by 3341.82 minus the remainder started at 34367.01. 155.38 times by 3341.82 minus 343,677.01. 175,574.98 to 2 decimal points. Therefore, total I is those numbers added together. 202,401.79 plus 277,904.66 plus 175,574.9898 655,881.43. Oh no, not again. I'm almost done. Default interest. To find interest saved, default I would have been 30 years, 360 payments of 3341.82 minus the, what did he start off at? 510 grand. 360 times by 3341.82 minus 510 grand. $693,055.20. I saved 693,055.20 minus 655,881.43. Take 655,881.43. $37173.77 interest saved. Whew, that was a big one. Statewide, Janet would need to consider tax implications, whereas Bill would not. Janet is investing, so earns interest, which is taxable income. Bill is taking out a loan, so no income to tax. Page 23 done. There is nothing else to write here. Well, that was a big one. This is like the best question they've ever asked. Apologies for that mistake. That was a bit silly, but I fixed it. Sorry for taking so long on the networks question, working out the dummy link. I'm a bit rusty. I'm doing this in the middle of the year. Normally I'd be doing this just before the exams, but I'm going on leave. Sorry, the question that I'm apologizing for was this one here. It took me a while to work that out, but it's good for you to see it's live. Hopefully this video helps you out. And I'll see you in the next one for 2025.